It's recording. Oh, I have to unfreeze. Ready? Ha! Everybody laugh.
Happy birthday, Noah.
So,
That was very well done.
do you like the smiley face in the O?
The font bigger, but the smiley face got bigger.
I did make it bigger.
That's what it does. Oh, that's how it works. Cool.
Okay. So you did the sheet for homework. How was it?
It was wonderful.
No, I just wired the numbers up for homework.
Oh, it's possible.
I did every single one from combination.
Oh, yeah.
I told you that. I had next week to go over 70 times. I was told that's why I got 2 out of my 7. And then 2 out of 7. And then 2 out of 5.
I got that for now. I got to try.
But for next step, I didn't know what I need to do.
I think with all of this, we need to. All right, so those are all the answers for the test next week. What questions do people need to ask about the homework before we go to new problems? Ben.
Okay, for 9, when you're finding all the zeros, it's -2, +1, plus or minus 2i. It's not included in the 2i.
Why wouldn't you?
Why wouldn't I?
Yeah.
Okay.
But not real zero.
So it seems to me. It seems to me that you're asking a question about like real zeros versus complex zeros. So in the same way that I could ask this question, could you please solve this? It sort of matters how I ask the question. If I ask you to solve this over the reals, you would say there's no solution. If I asked you to solve it over the complex number system, you would say that the answers are x's plus or minus 2i. So the context matters. Since I just asked for all the zeros and I didn't say the word real, it seems to me that you should go all the way through and include the plus or minus 2i. Which makes me want to say something about 7. Because on number 7,
I didn't get it because I got
how are you able to sharpen your pencil without Kelton here? On 7, before you went to the quadratic formula, Caitlin, what did you have?
you mean at the end?
You had x plus 2, x minus 3, x plus 3, right? Somebody said, Elizabeth, you had this one, right?
No, I have that.
I had that.
I also
But there's also a quadratic term.
X squared.
square minus 2.
Okay, so this brings rise to some important stuff. From this one, if we take this and quadratic formula it, you'd have that x is 1 plus or minus 1 minus 4 times 2.
That's back from 1. X
Opposite
plus
2
plus 1.
negative 1.
No, it's not.
Negative 2 off.
No, it's not factor.
Oh, you're right.
What?
Because
Oh, because it's plus.
yeah, it's plus.
Dang it.
What is this, negative 7?
We ate them all there.
Yes.
So you get 1 plus or minus,
7.
all right, I with 7 over 2. How many zeros do we have? How many complex zeros do we have?
2. So 5.
And then, right, complex also includes real. I have 5 total complex zeros. 3 of them happen to be real, and 2 of them happen to be in the imaginary world. Yes.
So we were asked to graph that. Can you?
Talk about graphing it?
Yeah.
Sure. What was the original function?
F of x equals x to the 5th. Plus x to the 4th minus 9x to the 3rd minus 5x squared minus 36.
Is this right? Okay, so the amount of graphing I want you to be familiar with is, what's the end behavior? TB for end behavior. It's to the 5th and it's positive, so it's going to rise up this way and fall down that way, right? And it's going to hit the axis at the real zeros. It's not hitting the axis of the imaginary zeros, they're not on the axis. So it's going to hit at -2, -3, and +3. So in the same way that we have parabolas that never touch the x-axis, we're not seeing those zeros happen. All right, so let's graph this. They all have multiplicity 1, so we're just passing through the axis. The reality is, there's other stuff happening. It could be that there's extra wiggles in here because of those imaginary zeros. I'm not really concerned about that. I'm concerned that you can do this. But it could be, so actually, let's look at this. We could look at the y-intercept. It's clearly negative 36.
Yeah.
So hold on, let's have a quick calculator look. Okay. What's it again? All right, you have to read it to me again, Julian, please.
What?
Can you read it to me again?
Yes, x plus up plus x minus.
I need to charge that area.
Oh, minus, hold on. Yeah?
And then plus, oh no, minus, sorry, 5x squared minus 36.
All right. So it seems to me that that kind of gives me some information, but I'd like a slightly nicer graph. What is it that I want to see? I want to see all those turning points. How could I do that? Like, what do I need to change? This is stuff you guys need to know how to do. I need to change my window. Now, you could just go hunting around with the zoom buttons. I think you're better off knowing how to change your window. So you'll hit the window button. Do I need to change? Oh, look, it's right here. Do I need to change the amount of x I see? No, I see those 3 real zeros, so that's seeming good. So I need to change the y's. Thoughts? Do I need to look higher and lower?
Yeah.
Okay, do you think by like a ton or a bit? Those are technical math terms.
Okay.
We'll try a bit first. How about we go with negative 30? And I have a thing about symmetry, though it doesn't have to be symmetrical. At a certain point, I can let go of that. Oh, almost. Right? Okay. So we'll go back to our window. I don't want to go higher than 30 again, but I do want to go lower. So how about negative 60? Why did I pick those? Because I did. There it is. Oh, so close. You can see that wiggle happen, though.
So we
A
go
little bit.
we go even less, negative 100.
That sounds good.
Pretty sharp turn.
Well, if we look on this scale for x's, yes, but if we change the x scale,
Oh,
it'll look
I
different.
got it. Wiggle. So weird. I got the wiggle. But is there a wiggle at the top?
No. So in the world of calculus, you get some really concrete ways to know where those wiggles happen. Because what's happening is the graph is changing in its shape. It's changing from like what we call in calculus concave up to concave down. In other words, it can sort of hold water in here and it dumps water in here. Like, see how it changes its curve? It's still decreasing the whole time, but changes the way it curves. Okay. Okay. So if I asked you to graph this by hand without a calculator and without knowledge, I would just expect what we did over there. We good? Can I go on to something else? Yes, Caitlin? Well, I was hoping to do some other stuff. What happens in 6 that concerns you?
Well, I just got a different answer.
Than everybody?
Why? I got just like 2 zeros, which I think is wrong.
Wait, I have a question. Does anyone have a calculator?
Well, if we go for complex zeros, then there would have to be 4 total zeros. What did you guys get for zeros for 6?
Negative 1, negative 3, negative 2.
And what did you get?
I got
I got negative 3.
So then you end up with something quadratic after doing those 2 things, right? So you got negative 2, you got 3, you got got -3, and you've got 1. You just all sick of those two. That's all.
I'm
Yes.
confused because in the graph, for the thing that we just did, you said it's decreasing but in different ways, but I zoomed in on it and it's increasing a tiny bit in the very middle of it. Is that normal? Like, does that make sense?
Yeah, it does make sense that that's possible. It doesn't have to do that, but it is possible. That just means it has extra turning points. And again, in my opinion, most of the details of that sort of stuff merge so nicely in calculus that I don't think that's what our focus is now. I think our focus is about the zeros and behavior.
So with calculus, we're gonna know exactly.
You can exactly locate every turning point and every change in
That's fun.
shape of the graph fairly easily.
Fresh to say the least.
It is funky fresh to say the least. So let's do some examples together. How are we doing on time? This is the 15th.
Don't enjoy the rational since it at all.
I don't really disagree with you. I enjoy it for some problems. In fact, I'm going to go out on a limb and say I think you're going to enjoy it for this problem. I do. Well, maybe not as much as I was hoping, but maybe. So if I want to find all zeros, and by all, I will say, let's solve this over the complex number system. So if we want to find all the zeros, what should I do?
List out factors.
Right, so I'm going to be using the rational zero set, the rational root theorem, to find the possible rational zeros, and they are going to be plus or minus 1, plus or minus 3 over plus or minus 1, plus or minus 2, which gives me plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3/2. Anybody disagree with me? Anybody need to hear more about that? Irritating though it is, fairly straightforward. It's certainly possible you would have a test question that has some absurd number of possibilities, and all I want is the possibilities.
Is it generally more likely for it to be a small number, or is it just you giving us problems?
I'm just giving you manageable stuff.
Okay.
No, it could be any. Okay, we ready? What number would you like to try, Eliza?
Let's go with positive 3.
Positive 3. Okay, 3, and my coefficients are 2, -2, 1, 2, -3. And Alice, of course, you're going to check to make sure it counts down properly. 4, 3, 2, 1, explode. Great. All right, ready? Synthetically divide, everybody. Anybody feeling good about this?
No.
Would you like me to keep going?
No.
Okay.
Ben discovered
It's, yeah, I don't know why I'm good at this.
You got it from you, Alice.
-1.
Negative
You
1.
want to do -1?
I don't want to do 1 now.
Oh, right. Remember the thing about 1? What was the thing about 1? If you sum them all up, you get 0. Do we?
It does.
It does, which means 1 is going to work. Do we still want to do -1? Sure, why not?
Is it, what is it, you add them all?
You add up all the coefficients. If they add up to 0, then 1 is a root.
Okay.
I tried doing that and I ended up with 3, but then I
It's a lot of space.
didn't match it.
Oh my god.
No, that's a 5. Hey, Andrea, you remember the thing that if we add up the coefficients and we get 0, then 1's going to work. If you add up those you add up these even,
Yeah, I know 1 works.
1 works. Let's do it. So off of these coefficients, I'm going to now do 1. This was a quartic equation, cubic equation. We're headed down to a quadratic. That's a 3. very happy zeros. They are very happy. Why wouldn't they be? What am I left with? Quadratic, 2x squared minus 2x plus 3. Does this factor? How do you know? 6. I like it 6, 2 times 3. Factors of 6 that make 2? No. So what are we going to do? Quadratic formula.
Four. Denominators.
You're right.
Then that just goes right down.
Why is it just plus?
Can you read that?
Can you just put it all over?
Totally. You could have written it as 1 plus or minus I root 5 over 2. If you're going to list the zeros, however, let's separate them. What did the question ask for in the first place? Oh, that's too big. It's nice to see the entire problem. It said find all the zeros. Okay, you know what we did? We found all the zeros. What are they? -1, 1. I'll write it the other way just because you want it. 1 plus I root 5 over 2. 1 minus I root 5 over 2. How many complex zeros do we have? 4. Imaginary zeros, we have 2. Complex altogether, we have 4. I have a question. Can you observe anything from all these questions we've had that have had imaginary answers come out about them? What do you know about them? What? They all have squiggles. I don't know that. Is that the eye? How many did we get this time?
4.
How many imaginary answers did we get? 2. How many did we get last time? What can you tell me about these two in relation to each other? Eliza?
Well, just that it's like the.
Go ahead. You don't have to give the.
I mean,
Give an
like
answer.
it has the plus or minus thing, which results in like, I guess you could say A plus BI, A minus BI.
A plus BI and A minus BI. What was the word for that? Conjugate. So when we get, so there's a condition for this and there's a thing that's going to come up. I'll go write it in a second, but we'll say it first. So we started with a polynomial that has real coefficients. And I think that's the only requirement. I don't think they have to be rational. No, I think they just have to be real. If A plus BI is a 0, then A minus BI is going to be a 0. Or for that matter, if you know that one of them is a 0, you know the other one automatically is. What that's called, I made a list of things that we may get to all of them today or may not. What do you think that's called?
Complex conjugate.
Well done. So what do you think it says? If A plus BI is a 0 of a polynomial with real coefficients, because if they have imaginary coefficients, that doesn't matter anymore. Real coefficients, then so is its conjugate A minus BI. I think that's a lot more words than what I think you probably all understand. While we're here, I have a question. How many of these things have we talked about so far?
4.
Right, we've talked about the factor theorem, the remainder theorem, and the rational zeros theorem. I just thought I'd list them as like things we formalized. The factor theorem was the thing that said if you get if a number is a 0, if c is a 0 of a polynomial, then x minus c is a factor of the polynomial. Right, I'll write that. P of x is my shorthand for a polynomial. Is that okay with everybody? P for polynomial. And what does the remainder theorem say? Ben?
That if you put in C, you see the equation, the answer will be remainder.
So it doesn't have to be C as a 0, but whatever,
Whatever thing.
oops. We'll write it this way. For all x, P of x gives you the remainder you get when you divide. Actually, I don't want to call it x, that's going to get confusing. I don't want to call it c again though either. How about we call it?
J.
M.
I'm going to go with m. For all m, P of m gives you the remainder you get when you divide P of x by x minus m. Again, more words than what I actually think makes sense. Whatever you get out from your synthetic division is the same thing you would have gotten if you had plugged the number in. Which means, if I asked you what the remainder was from doing synthetic division with something like absurd polynomial and the number 2, you just plug 2 into the absurd polynomial, or you could do absurd synthetic division. You get the same answer either way. Okay? Rational zeros thing. Do I have to write?
Yeah.
Possible zeros are factors of the constant over factors of the leading coefficient. I'll write that. Possible rational zeros well, while we're here, I suppose we should talk about some of these other ones, shall we? The fundamental theorem of algebra sounds really important, doesn't it?
Is it like the fundamental theorem?
I'm going to write it, and then you're going to interpret it. And you're all going to have this experience of like, oh, possibly you'll have that experience. We'll see what happens. Don't call it dumb. Find a different adjective. Degree. It's the highest exponent in the equation. If f of x is a polynomial, then it has at least 1 0 in a complex number system.
Does that by complex number system, does that mean real or complex?
It means complex. It means
Other than
it means all inclusive. How's that?
What if you have a negative 3? Is that not true?
That's not a polynomial. Okay.
Then why do you have to specify a word that is greater than 0? Doesn't it have to
I think it's just formality.
So basically you're saying if it's a polynomial, if and you're just saying that
If it's a
if
polynomial,
the
it has
base is
zero.
not zero.
Yes,
Polynomials have zero.
but it could be complex. Yes. I would actually argue it's more interesting to say, in the complex number system, you have n zeros. The degree of the polynomial, you have that many zeros, but some of them might be complex as opposed to real. I struggle with how to talk about that. Intermediate value theorem is a pretty important thing, so let's talk about that one. I don't know if I want to write it fancy pants or just say it. We'll do it this way. I know you guys know me well enough to know that, like, I like you to understand it more than know the formality of it, so let's make sure we understand it. Okay, so the intermediate value theorem says if f of x is a polynomial, and you look at the interval from A to B, including A and B, so the closed interval from A to B, and when you plug A in and you plug B in, you get different numbers. Okay, so let's actually interpret that for a second. You have a polynomial. You have 2 points you're thinking about on your polynomial. The y values of those 2 points are not the same. Okay, everybody okay? What do you know about polynomials? Do we like leap off of them and like jump over here, or are they continuous? They're continuous. So if I have 2 points on my polynomial that have different y values, then it seems to me that I can get like every y value in between them is represented by some x value. Does that make sense? That's what the intermediate value theorem says. But there's a punch to it that we actually care about even more in a second. So let me finish this. If f of x is a polynomial and you look at the interval from A to B, and f of A and f of B, the y values, are different, then f of x will assume all y values on the interval from f of A to f of B. In other words, sometimes it's written as there exists a x value that gives you any of those y values. But we're going to leave it
Can you
this
just
way.
say that for every y value between the max or minimum?
Between
They're
those
all
two y values, yeah, that's fine, yeah. Again, I want the understanding more than the formality. Okay, so here's what's interesting in relation to zeros. Doesn't that mean that if f of A is positive, this is just sort of example thinking, and f of B is negative, notice I did not give you any numbers. So if one y value is positive and the other y value is negative,
Well, it has to pass.
it has to pass through the x-axis. There has to be a zero. That's what's really exciting and important right now. Yes, aren't you excited? It's an important feeling?
But I feel like all these things will go without saying.
Uh-huh.
That's just
Yes, this is us formalizing things that we totally understand. If that's your reaction, we're actually in great shape. Because if your reaction instead is like, oh my God, the writing here makes no sense and I can't link it to what we're doing, then we have a problem. So I'm going to go with that. I also don't really expect to ask you to like spit these things back. I more expect you to like respond to questions using them. You'll see in your homework you're going to do a couple of questions that connect directly to the intermediate value theorem, and we'll probably talk about those next time I see you. All right, so if f of A is positive and f of B is negative, then there is a zero for the function f of x on the interval from A to B. The other thing I'd like you to get away from this experience is that like, okay, so I'm not being strictly formal about how I write them, but I want things like the phrase on that math language to mean something to you. And I think it does. Like, I think we're doing what we need to be doing with this. Okay? I'm going to ignore Descartes' rule of signs for right now because it's kind of interesting. I'm more interested in us being able to do problems. But at some point, we may talk about it. If we lose too many snow days, I might just reference it in the textbook and ask you to like do a quick writing about it so you've seen it and feel connected to it somehow. But I don't think, for me, it doesn't really make or break stuff in the same way that the rational zeros theorem seems a little unnecessary in our technological lives these days. Descartes' rule of signs sort of falls in that same category, though there's still interesting stuff that, I don't know, doesn't progress us quite as far.
How much less have we missed to snows?
I don't know. Oh, too many.
2 men.
Should we do the slightly harder one together?
Yeah,
Okay. Good answer, Alice.
that's what it's doing.
Yeah, you'll want space for this.
A lot of space.
Well, it's going to be synthetic division with complex numbers, so yes.
So any more space that the won't give.
Not necessarily. No, because I'm giving you the zero, so we don't have to hunt around for them. So you might be okay. Okay, so I'm telling you that 3 minus I is a zero of our polynomial, and I didn't finish writing this question. What is the rest of this question? What should it be, Graham?
What are the rest of the zeros?
Yeah, that sounds good. And by that, Graham meant all of them, complex, everything, which kind of makes sense since we started in the complex system anyway. Okay, so 3 minus I goes in the box. Coefficients get listed. 5. Hi, Duncan.
Hey, I have a Tor, do you mind?
No, I love Taurus. Come on in. 98 and negative 80. We are doing synthetic division. We're about to do one of those complex numbers. All right, so the system is exactly the same as it was before. We're doing the same thing. The 5 is going to come down. And I heard one utterance. Okay, so you have to give words to that noise, please. Eliza.
Then you have 15 minus 5.
I do. So why was the noise? Oh, because it's a little more complicated than a single digit.
Work out.
Oh, and then
Find out.
you I squared, so that you have.
How exciting is that? So what happens when I add? Oh, come on.
Plus 15, that's
Negative 23 minus 5i. Now what am I going to do?
Do it again.
foil.
I need to foil, so I'll go off here and do this over here. Negative 20, this is so exciting, what lovely numbers. Ready? Julian?
Yeah.
Help.
So first you have negative 69, and then minus. Oh no, sorry, plus. Yes. Plus 8i.
Oh, did you do them at the same time? 23 and 15, yeah, that sounds good. Except that, isn't that the no, you're good.
That's good. Right. And then minus.
Plus 5i squared,
Minus.
which sounds like minus 5. Have a lovely, nice to see you all. Negative 74 plus 8i, does that look right? Okay, let's make this tiny because it's in my way. Ooh,
You're probably the most recent classroom to get a smart board. You're probably the person who knows the most about it.
no, Larry's got me beat.
Nuh-uh.
Yeah, he really does.
I don't believe it.
Okay, well, maybe we should have a duel. You guys could come up with a challenge.
So much fun.
Have a smartboard duel?
Yeah.
I think that would be great.
Let's do it in like Lincoln Financial Field.
What happens here?
You add 94. I mean, what?
I get 24, right?
Yes.
Plus 8i. So you kind of need space for these. All right, here we are again. 24 plus 8i
What?
times 3 minus I better be negative 80, positive 80, but let's find out. 24 times 3 is 72, correct?
Yep.
Plus 24i minus 24i. Minus 8i squared.
Yeah.
So it's 72.
80.
Oh no, that was an eraser. How upsetting was that? I'll do it again. Flare it all. 24, Calvin, I don't want any responses to how messy that is. I was talking to Calvin.
Yeah, I got it.
Oh, right, we're still recording.
Yes.
I just forgot about comment.
I don't blame you. He's hardly, existent. Oh, we have to go back to page. So this is 80.
Yay.
Okay.
What if
That was
you do that, but using the
Wait,
possible?
what?
Well, wait, what happens next? That was cubic. This is quadratic. What do we do?
You could just.
You just
Going.
You just foil a ball.
What do you mean keep going?
What do you do this?
With what?
Oh no.
You can
3
maybe.
plus I.
What?
3 plus I.
I can do some kind of division again with 3 plus I. Why can I do that? Because of the complex conjugate blah blah theorem. All right, so we'll scoot this over and give ourselves some room. That is exciting. Thank you, Graham. 3 plus I. The good news is the second round of this always goes a little smoother.
Score.
Or not always, but this one's going to. 15 plus 5i. Look what just happens. Negative 8, right? Negative 24 minus 8i.
Yeah.
So could it ever possibly work out? Yes.
Yeah.
And what am I left with at the end here?
5x minus 8.
5x minus 8 because it went from cubic to quadratic to linear. Oh, look at those fancy pants math words.
8 fifths.
So if I set this equal to 0, I get 8 fifths. You okay, Noah? We didn't hurt you with that, did we? All right. He was saying, like, how can we possibly solve? It was sarcasm. I don't know if anybody followed it. You weren't in? So what are the zeros?
3 minus I. 3 plus I.
And 8 fifths. Anybody surprised that we had 3 answers?
No.
No, it was cubic in the first place. Gosh darn it.
Duh.
That was fun. How are we feeling?
Amazing.
So in my mind, we've kind of covered what's on the test, which doesn't mean we're going to move on. We're still on it. But in the event that like we didn't see each other until next week, I still kind of think we could do something, but you'd expect me to send you things. Here's what I think is going to happen.
Is it supposed to snow?
It's supposed to snow Thursday.
It sounds.
And when's
Wait, like Thursday is in like no school Thursday?
It sounds very possible there's no school Thursday. I don't know what's going to happen with Friday. I don't know anything. Please be mindful of what's posted. But my intention is to give you sort of like, this is the list, these are the things, probably a review assignment, maybe even with solutions. I know we sort of need to bring it all together, okay? I'm aware that needs to happen. If we actually have enough school for this to happen, I was kind of hoping we could revisit the Inspires and sort of do an actual quiz where we actually compare, where you actually know things, instead of it being the one out of the gate where you're just sort of making guesses and feeling uncomfortable, but having an experience where like, you're going into it with knowledge and can now show yourselves how much you know.
When did that come out?
Well, that's not going to count for a grade anyway, but I was imagining that would be Friday.
So it's not quiz, but it doesn't count.
Well, it's a quiz on the Inspire, but it's not a quiz I'm not quizzing you.
Oh, gotcha.
It's just that it
Can you
happens.
send those out to be inspired like from any distance? You just have to be like really close.
No, I think there's like there is a thing that I can't think of what it's called right now, but there's a thing, modem-ish, like, no, you have to be here.
Okay.
In other words, like, the ones in another room aren't going
Like
to be
take it
getting
home and
yours.
just.
Well, it is possible to give you an Inspire, load it onto it, you take it home, do it, bring it back and reconnect, which is cool.
That is cool.
Right,
It'd be cooler if you could just like beam it right out to us though.
like email.
Beaming technology.
Okay, I'll work on the beaming technology. But just be mindful, beaming technology probably involves mathematics. Are we done? And do I want to say goodbye, or are we just done with them?
Done.
But,
Let's talk about this tomorrow.
oh, but don't tell Calvin that.